Welcome to the lecture series on programming with problem solving. The topic is going to be the data type in C. So we have the different data types in C. And what is a data type? It is a collection of data with values having fixed values and meaning as well as its characteristics. There are different data types. You have the primary data type, you have the derived data type, and you have the user-defined data type. And here in this series, we will be discussing on the primary data type, which are integer, character, floating, double floating, and void. So here you can look into the different data types with its size and range and how it is specified in C. If it is a character, the size is 1 byte and the format specifier is %c, and here you have the unsigned character. It is also specified as %c, and you have the short data type and which is represented as %d, and you have the unsigned short data type. It is represented as %u when we do the coding, and you have the integer data type and that is represented as %d, and you have the unsigned integer. It is just shown as %u, and you have the long data type. It is represented as %ld, and you have the unsigned long that is mentioned as %lu, and you have the float which is a 4 byte size and it is represented as %f, and you have the double. It's mentioned as %lf in C, and you also have a long double which is also having the same format specifier as double, that is %lf. And we can see to the different ranges. If it is unsigned, it will have only the positive range from 0 to 255 if the byte size is 1, and if it is a signed, it will be like -128 to 127. So let us go on with an example of each data type. As you know, the integer data type, it is used to store the positive, negative, or the zero with any decimal values. And usually the size of an integer data type will be 4 bytes, and the syntax of integer data type is int variable name. So here you can see an example for how this integer data type work. So here, as usual, the first line, it is the standard input library which is needed for using the printf function, and the second line we have the main function which is the entry point of the program, and then we have the initialization of different integer variable. Here the integer variables are a, b, and c, and the first case it is taken as a positive n, and the second case it is taken with a negative data, and in the third case it is unsigned integer data, and the fourth type you have the long integer data. So you can see the representation with the plus, minus, u, and l. So if we request the compiler to print all these positive, negative, as well as the unsigned int and the long int with the appropriate format identifiers like %d, %u, and %ld, you will get the output like this. So when we ask to print with the positive data, it will print a 9, and the negative data, if we use this format specifier, will get -9, and we can also get the unsigned integer data as well as the long integer data. And the next data type is the character data type. It allows the variable to store only a single character, and the size of the character is 1 byte, and the format specifier is %c, and you can see to the syntax of the character data type, that is character variable name. And here you can see an example to this character data type. So here within the single quotes you are supposed to give the character, uh, which character you want to print, and here this character a is a variable name, character c, this c is a variable name, and if I am asking to print the value of a with the format identifiers %c, you will get the output as a, and the next line is incrementing a. That means what is next after the alphabet a? It is b. So after the increment, it will print the character B here. And even you can handle the you can assign the ASCII values corresponding to the character. So we know the ASCII value of small letter A is 97 and B is 98 and 99. And here if I make the assignment of C to be 99, and the compiler can print the value of C, not the ASCII value. It can directly print the character C because of this format identifier percentage %C. And then you have the next data type is float, and this float is used to show the decimal and exponential values with the single precision. So you can see to the syntax of this float data type float with a variable name, and here is an example to demonstrate this float data type. And here you can see the declarations are made as a float with the variable names A and B, and here the data is given as 9.0 F. This F indicates it is a float data type. And when we run this code, with this line printf percentage F slash N A means you will get the output as 9.000000. With the proper precision, you will get the output. And the second statement is float B 2.5 F, and if we request the compiler to print that B, you can get the output as 2.5 00000 with the proper precision. And here you can also give the exponential float values like 2 into 10 power minus 4, and it is written like this: float C is equal to 2 e power minus 4 F. And if we ask the compiler to print, it can give you the values of C as 2 into 10 power minus 4. Next, we'll move on to the next data type, that is a double data type. It is used to show the decimal values with a double precision. And here you can see the format specified to be percentage %LF, and it can store up to 16 to 17 bits after or before a decimal point. And the size of the double data type is to be 8 bytes. And here you can look into the syntax of the double data type, that is a double variable name. And here is a program to demonstrate the double data type. And as usual, we have written the header file and the main entry line for the program, and then we have made the declaration as a double data type with the different variable names as A, B, and C, and we have given different values. And if we ask the compiler to print the values of A, B, and C, you can see to the output with the same precision. And next we'll move on to the void data type, and this is used to specify that no value is present. It does not provide a result value to its caller. It has no value and no operations. Actually, void is used to represent nothing, but this void is used in multiple ways as a function return type, function argument is void, and pointer to void. And here is also an example to demonstrate the use of void pointer. And here you can see the third line. It is an integer variable val that is declared and initialized with a value of 30. And then the next line, we have the pointer of type void that is named ptr, and declared and assigned the address of the variable val. And the next line, we have asked the void pointer to be cast to the appropriate data type before dereferencing. Here you can see int star ptr, that it casts the void pointer. So we have the concept of casting and dereferencing that we'll be seeing into the next video. But as of now, you can just try to understand. Int star ptr, it calls the void pointer to an int star, that means pointer to integer. The dereferencing, this star is a dereferencing operator. It is used to access the value stored at that address which is printed, and this percentage d, it is a format specifier which are generally used, and for this program you will get the output as 30. And next you have the size of data type, which is an independent data type on the size of the architecture, and so we cannot define the universal size of the data type. So the C language, it provides size of operator to check the size of the data type. And here you can see a program to demonstrate the size of different data type. Here you can see the different data types of integer, character, float, and double. Here all the declarations are made, and if we use the size of, here you can see the size of the integer data type is 4, the size of the character data type is going to be 1, and the size of the float data type is 4, and the size of the double data type is 8. So we can use this size of to get the actual size of the data type. Thank you.